Welcome back to the channel. Many commenters have asked about the value of various AI algorithms, and let me assure you that I'm in favor of experimentation, and many new algorithms may bear fruit. On the other hand, I've been involved in AI for 40 years, and today's AI still doesn't have the common sense and understanding which every human possesses. So I'm pursuing the sure thing. If we can understand the techniques used by the human brain and can mimic them in AI, we'll assuredly have smarter, more robust systems. We aren't there yet, but we have a good start. In this video, we're going to step back and look at intelligence from a system-wide perspective. The human brain works by weaving together knowledge from many different senses into a single internal model. And our Brain Simulator 3 is designed to do just that in software. At its heart is the Universal Knowledge Store, a central hub where concepts, relationships, and rules come together, surrounded by modules for language, vision, and action. By connecting these modules through a unified graph of knowledge, we can begin to see how software can move beyond isolated tasks and toward something much closer to real brain-like intelligence. I'm Charles Simon, longtime AI researcher, software developer, and manager. Beyond AI, I've developed software for neurological test instruments and neural simulators. I created the Future AI Society to explore how neuroscience can inform smarter, more human-like AI. I'm using the open-source Brain Simulator projects for simulations and demonstrations throughout this video series. If you want to experiment on your own, you can download the Brain Simulator 3 from GitHub and try it out. In recent videos, I've shown why knowledge in your brain must be represented as a graph of nodes connected by relationships. While this idea fits neatly with the fact that your brain is a network of neurons joined by synapses, closer analysis shows that these nodes must be clusters of neurons, and the relationships must be represented by multiple synapses. This structure allows your brain to represent a simple fact like Fido is a dog, which immediately links Fido to a web of other concepts. Dogs have 4 legs, dogs are mammals, dogs bark, enabling inferences without memorizing each fact separately. I call this ability attribute inheritance, which is one key to the way your mind generalizes to create rules which greatly reduce the amount of knowledge we need to store in our brains. But these rules require exceptions. Penguins are birds, but penguins don't fly. And bidirectionality. You can ask, what is Fido? And you can ask, name some dogs. Unlike lists or databases, graphs naturally handle cause and effect reasoning and unify perception with multiple senses. For example, when a child sees a ball, the brain links the image to the concept of ball to the experiences of throwing and bouncing and creates predictions about what will happen next and what movements might be needed to catch the ball. This is how humans generalize, imagine, and predict. We can roughly split human thinking into 2 broad areas: recognizing things and situations in our surroundings and then acting on that recognition. This can be thought of as querying our current store of knowledge to detect things we can recognize and also adding to that knowledge store the new things we don't recognize. These processes also allow us to build an internal mental model of our surroundings. Beyond this, our brains include what I call agents, specialized processes that refine and organize knowledge. An agent might notice that Fido, Rover, and Spot all share a common attribute, like has a tail, and automatically bubble that attribute up to the general concept of dog. So the moment you learn that Rex is a dog, attribute inheritance lets you know Rex has a tail without needing further information. Other agents can create new classes of things like beagles, or instantiate individuals from those classes like Snoopy, or prune away unused information. Together, these mechanisms make the brain's knowledge graph both compact and flexible. This video now turns toward how we are implementing this structure in software in the Brain Simulator 3 project. At the core of the Brain Simulator 3 is the Universal Knowledge Store, or UKS. You can think of it as the brain's memory and reasoning hub, a single unified repository where all information is stored as interconnected nodes and relationships. The UKS isn't just a passive database, it's the place where inheritance, exceptions, bidirectionality, and generalization all come together to create meaningful knowledge. Without this kind of central structure, inputs would remain disconnected and outputs would be nothing more than pre-programmed reflexes. The UKS is a separate multi-platform software library which can be accessed via its API, which includes the fundamentals needed to add data, query, and control the UKS. Another important feature of the UKS is that it is fully multi-threadable. In practical terms, this means that multiple processes can interact with the knowledge store at the same time without slowing each other down or corrupting the data. One thread might be handling a vision module, turning images into objects and attributes, while another thread is simultaneously adding language input in the form of words and phrases, and yet another is running queries to answer questions. All these activities can happen in parallel, and the UKS makes sure that the knowledge base always remains consistent. This design is critical because a realistic brain-like system can't afford to process information in a single file queue. In the brain, vision, hearing, touch, and motor control are all working at once, constantly feeding and retrieving from the same mental model. Further, your brain's input streams are clearly handled in multi-stage pipelines where each stage adds a part to the recognition process. By making the UKS multi-threadable, Brain Simulator 3 mirrors this concurrency. Modules for perception, reasoning, and action can all interact with the central knowledge store in real time, just as your senses and thoughts operate simultaneously. Surrounding the UKS in the Brain Simulator 3 project are the modules that connect it to the outside world. This hub-and-spoke model means that every sense and every action use the same structure internally, the structure of the UKS graph. This architecture makes Brain Simulator 3 fundamentally different from most AI systems today. Instead of building separate models for language, vision, and robotics, each with their own isolated representations, this approach unifies them through a single graph structure. The result is that information gained through one channel, say learning that balls can bounce through vision, is instantly available to other channels like speech to say the ball is bouncing, or planning an action, I need to catch the ball. Just as the human brain integrates perception and action through its internal model, the UKS serves as the common ground for all modules to share and reason about knowledge. One of the most useful ways to understand how the UKS works is through the user interface in the Brain Simulator 3 app, which acts as a live window into the graph. The main display presents the UKS in a tree view where you can see concepts and their relationships branching outward. This lets you visually trace how a simple fact like Fido is a dog cascades into inherited attributes such as 4 legs, mammal, and alive. Changes to the data in the UKS are highlighted in green in real time so you can watch the knowledge evolve. Watching these relationships appear on screen makes the otherwise invisible reasoning process concrete and intuitive. To build knowledge into the system, the interface provides add statement and clause dialogues. With these, you can enter new facts into the UKS, defining a subject, a relationship, and a target. Clauses allow you to expand further, creating compound or conditional relationships, such as Fido goes outside if the weather is sunny. These dialogues make it easy to populate the graph step by step, whether you are experimenting with a few simple entries or constructing an entire network of interlinked knowledge. Finally, the interface includes a query dialog which allows you to ask questions directly against the UKS. You might ask, what animals are mammals? Or which pets have 4 legs? And watch as the system retrieves answers by following chains of inheritance exceptions and bidirectional links. This makes it possible not only to see how knowledge is stored, but also to verify how the system reasons across the network. Together, the display, statement entry tools, and query dialog turn the UKS from an abstract concept into a tangible interactive system. Ongoing development is focused on making the UKS more accessible and more powerful through new interfaces. One project is the ChatGPT interface, which will use a large language model to translate everyday English into structured UKS knowledge and queries. In addition to this, information can be bulk added to the UKS. The LLM can be treated as a source and generate hundreds of facts about any concept in a form which will flow directly into the UKS. Another major project is the vision interface, which converts images into UKS searchable information. Currently working on the MNIST database of handwritten digits, the target is that a photo of a cat on a chair, for example, can become a set of relationships. This is a cat, the cat is on the chair is furniture. By representing visual data in the UKS, the system can reason about what it sees in the same way it reasons about language, creating a unified model that ties words, images, and actions together. What we've seen is that Brain Simulator 3 is more than just a simulator. It's a framework for useful AI. The UKS provides a foundation where knowledge can be stored, inherited, and reasoned with, while the surrounding modules translate real-world inputs into structured data and outputs back into actions. With ongoing development, from natural language integration to vision interfaces, this architecture is steadily becoming a platform for experimenting with true common sense reasoning. I hope you'll join us on this journey toward building AI that doesn't just process information, but actually understands it. If you'd like to follow along, be sure to like, subscribe, and hit the notification bell, because the YouTube algorithm won't surface videos like this unless you ask for them. Then try out the software or join the community for free to participate in our online video conversations and our Discord server. Check them out in the links below. And as always, thanks for watching.